Thanks for coming to Parse Developer Day. My name is Kevin Lacker. I run the engineering team at Parse. And today I'd like to talk about something that's very near and dear to us at Parse: how to design great APIs. So first of all, what is an API? Well, the acronym stands for Application Programming Interface, but that might not tell you very much. The important word there is interface. When you're building a software library, the API is the surface that other developers will use. It's the interface that they will use to put your software inside of their application. As a software developer, unless you're building NAND gates and sticking together transistors, you're going to be using some software that other people wrote. So it matters to you what their API is like. Is it easy to use? Does it snap into your code without too much effort? A great API has these pieces fit together nicely. It'll be like using Legos, easy to snap together a lot of little bits to build a great system. A badly designed API, on the other hand, can be like off-brand Legos that you buy for a discount. And all the knobs are slightly too small, so you put them together, you try to build this great big castle, but then it all comes crumbling down. You don't want that. So why is this important to us at Parse? Well, at Parse, our whole product is an API that's designed to be consumed by other developers. API design is really important to us. If our API is hard to use, that means Parse is hard to use. So we don't just want our API to be good, we want it to be great. So what makes an API great? Well, an API has to actually work. It has to do what it promises. And that makes it OK. That's kind of table stakes. You have to have that. But I think to make an API great, it has to appeal to emotion. It has to appeal to emotion for the software engineer who is going to use it. So what emotion should it appeal to? For an API, what is the most powerful emotion? Is it greed? Well, an API can appeal to greed. An API can make you money. Or an API can save you money. This makes a lot of sense sometimes. Save money by outsourcing stuff to other people who can do it more efficiently. I think that's a value Parse provides. It's a value a lot of APIs provide. But I think a stronger emotion is possible. There's a stronger emotion to appeal to. Is it love? I do believe that it's possible to love a piece of software. We try to build Parse so that it can be loved. You can love software if you just can't imagine doing without it. Any project you work on, you've got to use your favorite tools. You've got to use your favorite API. But is this the most powerful emotion? Sometimes, even when you're happy or sad, you might still need to code. You need an emotion that appeals to you no matter what your mindset. A good API needs to appeal to the most powerful emotion: laziness. So I was thinking of how to find a stock photo that really represented laziness, and it was tough. And I realized that maybe the best way to symbolize laziness would be if I just didn't even bother finding a photo for this slide. For a software engineer, the most powerful emotion is laziness, no matter what sort of mood you're in. If you're happy, you still don't want to do a bunch of extra work that you don't have to. If you're sad, you're rushing to meet a deadline, no matter what, it's nice to be lazy. A good API will let you be lazy. A great API will empower you to be really, really lazy. So how exactly does an API let you be lazy? Well, I think there's three important qualities here. An API has to be intuitive. An intuitive API lets you be lazy when you don't need to spend a bunch of extra effort figuring out how it should work. You just listen to your intuition, and that tells you. The second thing that lets a developer be lazy is when their APIs have great documentation. There will always be some problems that are a little bit tricky to intuit the answer to. And if you can figure it out by checking the docs, rather than going through an exhausting process of trial and error, it'll let you be a bit lazier. And finally, a great API should be opinionated. There's going to be a lot of cases where it's not clear what the right way to design something is and what the wrong way to design something is. And an opinionated API means you don't have to think that hard about it. You do it the way that the API opinionatedly encourages you to. So let's get into this in a bit more detail. What does it mean for an API to be intuitive? So none of us are born knowing anything about computer programming. Nothing is intuitive in the sense that it's intuitive to crawl or to walk. And we also don't really learn computer programming from books or from classes as much as we do from practicing computer programming. So an API is intuitive when it works just like something that you've already seen before. The key principle here is that similar things should look similar. When you encounter something new about an API, if it looks really similar to something you've already seen before, then you'll know how to use it. So as an API designer, if two things kind of work the same, they should kind of look the same. So let me go through some examples. I'm going to pick some examples from the standard libraries of scripting languages because I think these are pretty commonly used. So this is an example of how to do some simple stuff in Ruby. Here we have checking the length of a string and checking the length of an array of numbers. OK, so up top, we're checking the length of the string bacon. You stick .length on the end of it. The length of this string is 5. There's 5 letters there. So to someone who's never seen Ruby before or never checked the length of anything, this won't be intuitive, and you'll have to learn it. You learn the rule, OK, I stick .length on the end. But then, if you go to arrays, the same principle applies. You have achieved 1 unit of laziness. Because you don't need to look up the docs for arrays. You can just say, it should work the same way as this other stuff. And you'd be right. So this is a pretty cool part of the API. If you look at, say, Python, there's a similar principle at work here, even though it's not exactly the same. Here, instead of .length, you call a len function on your string. OK, len of your string is 5. As a Python developer, you have to learn that. But if you then go and try to figure out how arrays work, well, the principle of intuition is going to stand by you pretty well here. You also call len on the array. So it's OK that it doesn't work the same way as Ruby. If it's working the same way as the other things in Python do, then it's intuitive. In case you think this is too obvious, here's an example where it doesn't quite work so well. In fact, in slightly dangerous of a way. In Perl, at first it looks like Python. You call length on your string, and you get back 5. But if you try the same trick on an array, you take this array that has 3 things in it, and length returns 1. Now, there's a rationale here. It's actually taking the array and reinterpreting it in a scalar context. But the first point is that's kind of a boring thing to understand. And the second point is that if you tried to use your intuition, not only does this not work, it could be doing something wrong, and you wouldn't even realize it. Just in case you were hoping to learn some Perl from this talk, here's the right way to do it in Perl. It's actually a different function. You call scalar on the array to get its length. So there's a lot of rationale behind it, but there's a reason that the more recent languages don't do it this way. So this principle that similar things should look similar is something that, while we designed Parse, we tried hard to take into account. One example is the most basic data structure in iOS, the PF object. When we were designing it, we looked at what was the most similar thing that already existed, the NS Mutable Dictionary. This is basically a hash table. We thought it's pretty similar because there isn't a fixed schema. In your code, you can change it if you want. And so here's how to do these things with an NS Mutable Dictionary. It's how to add something to your object, how to get something out of your object, how to remove a field. So as we were designing PF object, we thought we would make it work exactly the same way. If you know how the NS Mutable Dictionary works, it works the same way in a PF object. We use the same principle in Android. Here, the most similar object is a map of a string to just any object because of the way that we handle schemas. These are the same methods. They're different. They look different from iOS. But when we were designing Parse object in Android, we use the same principle of similarity, that if you know how a map works, you should also be able to do these things on a Parse object. So this principle of making similar things look similar, it works pretty well for designing the easier parts of your API. Whenever you're implementing a method that something just like it already exists, OK, name it the same thing. That's pretty straightforward, but it's not going to carry you through designing your API, all of it. But you can extend this principle. If you keep designing the smaller parts of your API in a way that is similar to the other smaller parts, eventually, as you build a larger, more complicated API, you'll find larger scale similarities. It's like building a building. If you start making all the smaller parts the same, the doors, the windows, the walls, when you design a larger building, it should be symmetric, its shape should be intuitive to you, and it should be stable and less likely to fall over. There, I might be stretching the metaphor a bit. A good API will work just like this. If you can see 7 of the 8 corners of a cube, it should be intuitive to you where the 8th one is, even if you can't see it. So this might be a little tricky. Let me go into an example. Here's some stuff you can do to strings in Ruby. This first example, .capitalize. Okay, this, not intuitive in and of itself, but this creates a copy of a string that's capitalized. There's another method, capitalize with an exclamation point. This works just like capitalize, but it destroys the string you call it on. It mutates it in place. If you're learning Ruby, well, you can't be lazy for either one of these. You have to just learn them. But as you look through the string library, you'll start to notice a pattern. Calling .reverse, well, that reverses a string and makes a new copy. Calling reverse with an exclamation point reverses it and mutates the original string, destroying it. So maybe you're starting to see a pattern here. .chop makes a copy of a string and chops off the last letter. So let's say we've never seen a method that chops off the last letter of a string in place. We're trying to guess what this method would be named. Do we have to check the documentation? No. It's chopped with an exclamation point on the end. The same pattern goes through all of these naming principles. In a way, you're using the building block of stick an exclamation point on it to construct larger, more complicatedly designed functions from each of these old functions. Now, even if someone has never seen any method before that chops a string in place, they can guess that it exists, they can guess what its name is, and they can guess what it does. When you're using an API and you just guess that a method should exist, and you guess correctly, it does exactly what you want, it feels like you're a magician. We try to use this principle as we design Parse. So here's another example from the basic object, and this is in Java. So here's a few things you can do with an object. One of the most simple things you can do is save the data that you've accumulated. The simplest way to do this is to call save. Now, this blocks the calling thread, so in a lot of situations, probably most situations, this isn't what you want. So we built some slightly more complicated versions to do other stuff you might want. Save in background will fork off a thread for you, sort of. It'll just handle the threading. You don't have to worry about it. And save eventually is even cooler. It'll save your object even if there's no network connection right now. There's an offline queue, and it serializes operations and does all this complicated stuff. But you don't need to worry about it. The point about save eventually is it'll save the object, eventually. So let's look at another part of the Parse API that we use the principle of parallelism to design. Another thing you can do with an object is to delete it. So you might go and learn that calling the delete method deletes an object and locks up the calling thread. If you were just using your intuition to imagine the other things you could do to this object, well, there's a pretty simple principle that once you learn it, just tells you how the other stuff works. There's a delete in background, which works just like save in background, but you're deleting instead of saving. And there's a delete eventually, which works just like save eventually, but it's deleting instead of saving. This is intuitive design because you don't need to go read a manual to understand this. Once you understand the names of enough of the API, the rest of it should feel obvious. OK, so far, we've talked about a couple ways to make an API look nice. Usually, that's what you want to do. But sometimes, there are exceptions. And there's one important exception. One important time when you want your API to feel ugly. And the principle here is that ugly things should look ugly. It's OK to look ugly sometimes. Sometimes it's actually what you want. If your API is doing something dangerous, something that might blow up your system, then it's OK for the methods that do that to look ugly. It's good for them to look ugly, because you start using it and you feel afraid. Why am I using this ugly thing? Am I doing something wrong? There's sharks circling me in the water. What's going to happen? I better be on edge and get ready to freak out. So let me give an example of something we ran into at Parse a long time ago. We've fixed this since. But at some point, we had the Ruby MongoDB driver to let our application servers talk to our backend. And I think I was going through and picking some options for the database, and this looked good to me. Hey, I'll set refresh mode to sync. That sounds great. Why would I want my refresh modes to get out of sync? That doesn't sound like it'd make anything easier. So I set this and I moved on. And honestly, I didn't really take the time to learn what I was doing. I was trying to be lazy when I really couldn't, because actually what this method does is every 90 seconds, it tells your application server to stop everything it's doing, stop all processing that hits the database, and wait until it has a consistent view of the network. In a system with any amount of traffic, basically turning this on just means that your server crashes frequently. So it might have been a more accurate name to call this just crash server frequently. At least if the method was named crash server frequently, then we're thinking, why is our server crashing frequently? And we look through the code, we could have gotten to this point and said, hey, maybe we should turn crash server frequently to false. I would have felt pretty good about making that change. So I'm being a little facetious here. You don't really want methods named crash server frequently. If you're adding stuff like this to your API, you should probably just leave out that option. But in practice, there are a lot of ways that you can add a little ugliness to have a feeling of danger. For example, this could have been called global lock and refresh equals true. This still sounds like a professional thing that you might want to do. But if you have enough experience in software development, you start to learn that a global lock that does any sort of thing is a source of danger. If you're using a global lock for stuff in a performance system, you should start to think, wait a moment, the sharks are in the water. I don't need to think about this. Maybe I should get a couple other people to check out this code. This name is ugly, but it's still good API design, because it's doing something ugly. So let's go on to the next thing that makes an API great. Great documentation. It's easy to think of documentation as something that's secondary to your main product. And for some products, this is true. If you buy a new iPhone, you take it out of the box, you turn it on, you start poking it with your finger, you play some games, you don't need documentation. It works really well without it. And you can just design it to be intuitive enough to not need documentation. For an API, this is impossible. For an API, people using your product will be doing things so complicated, you can't possibly let them do everything without needing to check the documentation. One way to think about it is that lines of code can be really powerful, because one line of code can save hours and hours of work if you were doing it manually. Well, documentation has the same power. One line of great documentation in the right place can save hours and hours for just one single consumer of your API. It might tell them that something is possible, that they don't need to go build it themselves, that all they need to do is use this method that they've never heard of. So making great documentation is really important to us at Parse, and it's something that we really work at and think about how to make better documentation. So I think the overriding principle for great documentation is that simple questions should be simple to answer. You can think about your documentation almost like a data structure. If you're an engineer trying to approach what is an English language problem, it can be easier to think of, hey, we're just building a hash table here. We're not doing something as complicated as writing paragraphs. Ugh. If you have a simple question, you should be able to get the answer out of your docs in O of 1 time, in constant time. You should never have to hunt through all of your documentation to find the answer to something. So one way to figure out what sort of documentation you need is to think of what are the simple questions that you want your docs to answer. I have a few examples here that I think are really important. The first question is, what does this do? Someone is reading some code that uses your API. They're confused about how it works, and they want to check out what it does. I saw a method call on an object I'm not familiar with. What does it do? This sort of question should be answered by your reference docs. Your reference docs are like a dictionary. It's OK if your reference docs are boring. No one is going to read them straight through. No one reads a dictionary straight through unless you're David Foster Wallace. So it's all right if they're boring. What they should be is exhaustive. A lot of languages have a standard mechanism for creating reference docs, like Java doc, JS doc. Use these when it exists. Make sure to fill it out with enough information that whatever question a developer might have, you can answer it in your reference docs. One case, though, that isn't caught so well by these automatic generation tools is web endpoints to your API. For Parse, I think we've done something pretty cool here. So this is a little example from what is essentially our REST API reference. Here, we give you an example in curl that you can just paste into an application, in this case, maybe a bash script or something, or just to test things out. And it should just work directly. We have a drop-down for many of the common languages that people use, so that in as many cases as possible, you can just paste some code into your app. If you're logged in, there's another drop-down that will automatically put the authorization keys from your app into this sample code. So you really can just paste it straight into your application. This isn't just a static document we built. This is software that we built to power our documentation. It's engineering effort that we put not just into our API, but into the documentation for our API. It's a lot of effort, but it's worth it. The next question that your documentation needs to answer is, how do I do something? You hear somewhere that Parse is great for push notifications. OK, now what? How do you even get started from there? You don't necessarily know what to do. You don't know what is the first key on the keyboard you should hit. So you start out not knowing much except the general topic you're interested in. This question is for your tutorials or your guides. Your tutorials should not be boring, because it should be interesting to just read straight through them. They're like textbooks. They should each cover one topic, and that topic should make sense to someone who isn't very familiar with your subject. Just like you might have a textbook for algebra, you could have a tutorial for a subject like push notifications, or for implementing a login mechanism. They should be interesting to read if you're just kind of bored and you want to educate yourself. So at Parse, I think we do a pretty good job of providing different tutorials. You do need to make one boring decision of what operating system you're using, but that should be pretty straightforward. And then we try to keep the number small enough but broad enough so that if you're just kind of curious and want to learn more, browsing through our tutorials is a great place to start. So the last question that's important that your documentation answers is, what can I do in 2 minutes? You told your boss, hey, no problem, I'll have the first cut of the mobile app done today. You've been lazy all day and you got nothing. And your boss comes by. Oh man, I got to get going. I'll do the absolute fastest thing that will give me some work that I can show someone else. This is a lot more common of a case than we might want to admit. How can I do something? Anything at all of any value? It's just got to be fast. This is a question for your quick start. A quick start should be like the safety card in the back of the seat in front of you on the airplane. It's as simple as possible, using instructions that are so simple that you can understand it even if you don't speak the language well, if the reader is inexperienced, or tired, or drunk, or just really lazy. Your quick start needs to answer the question of, how do I do something that has any value as fast as possible? So here's an example of a quick start I think is really cool. This is the quick start for RVM, which is the Ruby version manager. You probably don't know what this is, but it's fairly complicated software that lets you run different Ruby environments on one machine at the same time. It's something that normally you would want to be very delicate and take a lot of care in setting up, but you don't need to. To install RVM, if you just paste this one line of code into a terminal, it will go and set up RVM for you. It will muck around with all these config files, do all this stuff, change your Ruby environment everywhere by default, and do all these things, and all you need to do is paste this in. It's also insanely dangerous. As I was making this slide, I was afraid that I would sneeze and accidentally slip and paste this into a terminal of mine and take hours of work to undo this mistaken install. Because this is just saying, let me download some code from the internet and run it with no future checks of any kind. Despite the danger, I'm pretty sure that a lot of people, given the opportunity to save a couple minutes of work, just opt for the dangerous solution. I wish at Parse we could make our quick start this quick. Unfortunately, we haven't quite gotten there yet. I think we're doing pretty well, though. You do need to decide what operating system you want, whether it's a new project or an existing project. But after that, we try to give you the minimal number of steps, explain them really simply, to make Git going as fast as possible. Make it as fast as possible for you to go to your boss and say, hey, I already got the first version of the mobile app going. You know, chill, man. So if you have good reference docs, good tutorials, and a good quick start, then I think you should have pretty good docs. The last part of making a great API is that it should be opinionated. So far, the things I've been talking about, well, they're pretty much facts. Nobody is going to say, you should design your software so that it is unintuitive. Or say, your documentation should be hard to read. No one is going to come and advocate these principles. But doing the parts that everyone agrees on isn't quite enough. Your API has to be opinionated, especially in cases where there's some sort of eternal debate. There are many eternal debates in software design. Should an API be strictly RESTful? Should objects have mutable state? Which is better, JSON or XML? Should method names be snake-cased or camel-cased? Well, if you're just an individual living your life, it might not be the right thing for you to take strong sides on all of these. It might make you a more well-rounded person if you understand the pros and cons of each strategy. And you can really see that there is a balance. Building APIs is different. When you're building an API, you have to take sides and pick who's right. Pick a direction and run with it. Create a philosophy. Parse likes JSON. We use mutable objects. Our API is not strictly RESTful. These are little pieces of the Parse API design philosophy that we have strong opinions about. So why is this important? Well, let me go back to some scripting language standard libraries to give you an example. So here's a string library that has a coherent philosophy. You know, here are a few methods. The top one is how to repeat a string, and then how to split a string into smaller strings, how to count the number of words in a string. You can see there's kind of a nice naming philosophy going on here. If I had a new method, I'd probably know what it would be called here. You put stir underscore on the beginning, and then you have the other words. You separate them with the underscore. OK, this is an OK philosophy. Maybe I'd prefer string underscore instead of stir, but this is all right. All right, now let me talk about a different philosophy. Here is a totally different way to build a string library. In this philosophy, method names are just a really small number of characters all glommed together. This is how to compare two strings, how to check the length of a string, or reverse a string. This philosophy is great if, maybe you have cuts on all your fingers and it's really hard for you to type. So you need to use as few letters as possible. Then you would love this method of design. So this is also intuitive. If you took, for example, the word count method from the previous slide and implemented it here, you can guess what it would be called, probably strwc. So that makes sense. Each of these are OK ways to build an API. Unfortunately, these are actually the same string library. This is the standard PHP string library. This is not so great. If you're a PHP developer, this means you can't use your intuition when it comes to string functions. For every single string function, you need to memorize which of the different philosophies it was named with. It's just a constant pain while you're developing. In fact, this is so obviously not good that it's worth asking, how did it get into this situation? Was there someone who thought, according to my aesthetic principles, it's important that we use this naming strategy? No. What happened is that different people built these different things, in a way that seemed good to them, and then when you put it all together, you end up with the dog with the horse's head on it. The problem here is you can't clone yourself. If you're building an API with much value at all, pretty soon you'll find that it's worthwhile to put more people towards the task of building an API. If you're just one person building an API, your philosophy can be, well, I'll just do things in the way that I think is best. You know, that's OK at first, but when everyone just uses their own principles of design, everyone could be individually intelligent, everyone could be designing things in a way that makes sense, but when you put it all together, you end up with something that looks like the PHP string library. The solution to this problem is to be very opinionated. Spread your philosophy, especially among your team, but also among developers using your product, so that everyone can think alike. Everyone building your API needs to think alike. You need to be opinionated even when there is no right and wrong. You need to be opinionated especially when there is no right or wrong. When you're designing something, you should not just build your endpoints. You should also create a philosophy and the naming conventions and the principles behind it, and share it with your coworkers. You might need to share it in such an aggressive way that everyone really, really agrees. But if you're sitting next to someone and you really like JSON and you really like XML, well, you shouldn't just sit down and start going. You need to argue it out up front. Pick one way, run with it, and your API needs to stick to that forever. This will help different people think alike and build an API that feels like it was built by just one person. So I've told you a lot of things that everyone should do all day, and I don't mean to imply at all that Parse is perfect. I want you to call us on it. We appreciate not just bug reports, but also imperfect design reports. Let us know when you think that something isn't intuitive, or that the documentation doesn't make sense for a feature, or when two different parts of our API feel like they were built by different people. Drop us a line, or find me around the rest of Parse Developer Day, and let me know what you think we could have done differently. So thanks for listening. I hope this has given some insight into how we design the Parse API, and maybe some helpful tips for how you can build your own software. Thanks again, and enjoy the rest of Parse Developer Day.